We have reached the top of the hour, so let's go ahead and dive right in. But before we do, actually, I will ask all of our listeners in the audience if you would please take a moment and find the tweet that has this Twitter space on it, and go ahead and just tweet out real quick and share this space with your followers so that they come join us. And we'll give everybody just another moment to do that, and then we'll get started. Okay, awesome. Well, let's go ahead and dive right in then. Today we have joining us from the Succinct team, Uma, up here on stage, and then I am Britt, joining from the Across team. Welcome, Uma. How are you today?
I'm good. How are you?
I'm doing wonderful. Thanks for asking. And am I saying that right, by the way? Is it Uma?
Yeah.
Okay, great. Perfect. Well, thanks for joining us. Let's go ahead and get started with some questions from our team for you. So the first question that I have is just, can you give us a general introduction of yourself, Succinct Labs, and the team?
Yeah, definitely. So, yeah, I'm Uma. I'm one of the co-founders of Succinct. In general, we're working on making interoperability better. So today, cross-chain interop is pretty broken because most, bridges are run by permission multisigs or centralized entities. And then, as I'm sure you guys all know, they get hacked all the time. And some of the biggest hacks and exploits in crypto have been bridge hacks. And basically, this is pretty unsustainable for the space, especially as we move towards this very multi-chain, multi-rollup future. And so at Succinct, we're really focused on making interoperability better, but making it more secure, more decentralized, more permissionless. And the first thing we launched as part of this was our protocol Telepathy. So what Telepathy does basically is it's a ZK Snark proof of Ethereum consensus. So maybe to take a step back, at Succinct, we think that the best way for two chains to talk to each other is for both chains to verify each other's consensus. And we think the best way to do that is with ZK Snarks, which is kind of this new technology that a lot of people in crypto are excited by, and it's being used by ZK rollup teams for scaling Ethereum as well. So yeah, we're basically applying that technology to make interoperability more trustless, more secure, and more permissionless. And yeah, I can go into more details on that later because it's there's definitely a lot there.
Yeah, awesome. Thank you. I actually was going to say that's a good segue. Maybe we should take a minute really quick, and if you would, tell us a little bit more in layman's terms how ZK Snarks work.
Yeah, so basically, or maybe we can start with what a ZK Snark is. So what a ZK Snark is, it's a cryptographic primitive that lets you compress computation and basically do verifiable computation. So if I have some statement that holds true, for example, the sum of these numbers is this number, or the hash of this number is some other number, what ZK allows you to do is a few things. So ZK Snark stands for zero knowledge, succinct, non-interactive argument of knowledge. And so there's kind of two properties it has. One property is that if I have some function that's really computationally expensive, for example, I take a number and I hash it 1,000,000 times, I can generate a proof for this computation. And the nice part is that the proof takes much less time to verify than doing the original computation. And the person who's verifying that proof has confidence that that computation resulted in the given answer. So this is really nice because it's, for example, in the context of blockchain, where you have one state and then you apply a bunch of transactions and you arrive at a new state, you can basically take those computations of applying the transactions, you can generate a succinct proof for it, and then anyone else can verify that you apply the transactions correctly, so you're not, maliciously setting balances and stuff like that. And so that's why ZK, the succinct part of ZK Snarks, which stands for this kind of verifiable computation, is really interesting to people for scaling blockchains. And then the ZK part, which is the zero knowledge, is useful for privacy in blockchain. So that just means, for example, if I have some function, I can compute the result and get the result, and the input can be hidden from me. So I wouldn't know what the input is, but I can still verify that this function applied on some input, I don't know what it is, results in this answer. And so that's useful for privacy because you can show like, I deposited it into this pool and I'm going to withdraw it from it later, but I'm not going to tell you which depositor I exactly am, but I'm just going to tell you I'm one of the depositors. So that was kind of like the tornado cache construction. And yeah, in terms of describing like some of the technology behind it, I think that is like a little more, technically challenging. Like I think a lot of the math that powers this ZK Snark tech is fairly advanced, but I think there's a lot of good resources to learn about it. At the highest level, it involves like turning your function into a statement about polynomials, and then you prove basically that polynomials have like certain equalities that hold between them. And then there's a variety of ways to like, do that. Some involve like elliptic curves, some involve like hash functions. So yeah, that's like a very 30,000-foot view of how ZK works. But yeah.
Wild. Lots of lots of terms that I haven't heard since the last time I took a math class. So, awesome. Right on. So then let's talk about telepathy specifically. So with telepathy, developers can request arbitrary Ethereum data from any EVM chain and access Ethereum consensus data in the execution layer. So then can you provide some practical use cases for those features?
Yeah, definitely. So I think what telepathy is again, it's this like client for Ethereum. We implemented the verification logic of consensus in our ZK circuit. So what you can do with this is you can run a really efficient on-chain Ethereum like client. And so that can be used for a few things. One thing it can be used for is sending messages from Ethereum to any other chain. And so, because what we do, for example, is on Avalanche, we'll run this Ethereum like client as an Avalanche smart contract. It'll keep track of Ethereum headers. And then when you send messages on Ethereum, we can just verify on the other side that you sent the message. So with Avalanche or Binance Smart Chain, which is what Across is using for it, you can send messages from Ethereum to those chains without the need for like a multi-sig to sign off on these messages. And you can also do this for sending messages from Ethereum to any other chain. So that's one use case, and that's like, for example, what you guys are using us for. The Gnosis team is also kind of using us for this use case because they want to secure their native bridge to their ecosystem. They're an Alta one as well. Some other use cases beyond messaging are reading consensus data in the execution layer. So this is really useful for a bunch of liquid staking protocols. So for example, right now, if you're Lido or your Rocket Pool, you have to have some Oracle, which is like a multi-sig, basically take your validator balances from the consensus layer and then update them in the execution layer. And that's something we can do with our light client, because really our light client is an Ethereum consensus light client, so it knows information about the consensus layer. And so we can trustlessly access information about validator balances and slashings and things like that in the execution layer, which is really helpful for making liquid staking protocols more secure. So that's kind of another use case of our light client. And then the last one that's interesting is, for example, if you have some state on Ethereum that you want to read on another chain, and it could be any chain, like it could be Optimism, Arbitrum, or like some other Alta one. Say you want to read like how many tokens does this account have, or how much like is this function on Ethereum result in saying like who the owner of this NFT is, or anything like that. That's also something that we can do for you. It's basically like an Ethereum oracle. We think of it like that. So like any function or any data you want to request from Ethereum, we can fulfill that request through our system and have it be secured by the same technology. So yeah, it's just like a few different ways of using the product.
Super interesting. So one of the things that I didn't realize until kind of recently was that these messages are one way from Ethereum to these layer 2 chains. And can you explain a little bit more? Are there any limitations on that being a one-way message, or in the future, will we be able to send a message back? Or maybe just help us understand why that's one way.
Yeah, definitely. So the reason it's one way is for example, if we wanted to do it two ways, we'd have to implement a light client for the other chain and run for example, an Avalanche light client on Ethereum. So that's something we're actively working on, is making all our messaging two-way. But for now, we have this Ethereum light client, which is one way. And then we're basically actively working on implementing the other light clients so that we can connect all the chains.
Awesome. Nice. I know for across, it's not a limiting factor for us. We really only need it to be a one-way message, so that's good news. And it's cool to hear that it's coming in the roadmap and it's not an inherent restriction on the technology itself. So super cool. Thanks. All right, next question. So many users are still pretty wary of using third-party bridges despite the benefits of speed and sometimes cost. Can you explain how Telepathy's approach to interoperability sets it apart from existing solutions and why it's particularly appealing for those who have security concerns with cross-chain bridges?
Yeah, definitely. So I think, definitely users' fears are not unfounded when not wanting to use third-party bridges, because of all the hacks and like all the trust assumptions that are kind of strewn throughout this space. So for Telepathy, one thing that's interesting is we, unlike other solutions where basically they're a multi-sig where they can like arbitrarily censor your transactions, or if this multi-sig gets hacked, then your transaction might do something totally incorrect, and like not give you the money on the other side and things like that. For us, because it's secured by this like layer, ZK layer, there's no centralized intermediary. So like anyone can generate the proof, anyone can submit the proof to operate the light client, anyone can relay the messages. Like all of our contracts don't have like only owner on all those update functions, which is really nice. So basically it's more permissionless, which means like anyone can operate it. And then also it's more secure because it's not relying on some multi-sig not getting hacked. We're just relying on like this basically proof, which the ZK proof, to verify that certain like state is true. So yeah, I think it kind of like resolves a lot of the security concerns that people might have around bridges. And then especially when paired with something like a cross liquidity layer on top, where the relayer is the one who fronts you the money very quickly, and then they get reimbursed later. I think that's actually a really nice system because basically the user gets the funds like no matter what, or you're not really trusting the relayer because if something bad happens, there's like a whole dispute resolution process. So I think a lot of the liquidity layers, actually like the people who are fronting you the money, take on more of the risk. And so that's also especially nice for the user because you get your money like much faster than a native bridge, for example.
Yeah, totally. I had a question in my head that was a follow-up question from something cool that you said. Shoot, I've forgotten it. That's okay. Can you tell us, so right now, what are the chains that Succinct supports?
Yeah, right now we support going from Ethereum to Gnosis chain, Avalanche, BNB chain, Optimism, Arbitrum, and Polygon. And one interesting thing to Gnosis is actually an Ethereum clone chain. So basically, it has like the same consensus as Ethereum. So we can also bridge bidirectionally between Gnosis and Ethereum.
Oh, that's cool. Nice. And then what are the chains that you'll be onboarding next?
So that's like still TBD as we work on our V2. I think for any other EVM chain, we can really easily support messages from Ethereum to that chain, if people want. So that's nice for us. We can also support like other execution environments as long as we implement like our like client in their execution environment. So, and our like client contract's not that big, so that's definitely possible as well. So We are also working on, as I mentioned, these like clients for these other chains and bridging information back. And so, that's something we're like trying to actively decide on and prioritize. But then I think there will be more details about that like relatively soon.
Yeah, totally. That's kind of a similar conversation to one that we have regularly, which is the space is growing so quickly. You have to sort of decide which things to prioritize, and it feels like there's a new chain to support every other week, basically. And so,
Yeah, definitely.
trying to deploy to all the new chains is kind of tough, but very cool. Thanks for that. So then, with the growing demand of this space and cross chain transfers, especially to like less and less compatible chains, how do you see telepathy and Succinct Labs as a whole influencing the future of interoperability?
Yeah, I mean, we think interoperability today is like pretty broken. And so we imagine that in the future, hopefully, with interoperability, there's like not as many trust assumptions, not as many multi-sigs. Everything kind of flows through these like permissionless, decentralized systems. Everything's much more secure and there's like no more hacks. And yeah, basically, everything is secured by these like proofs of consensus or these succinct proofs of consensus. And it like, all that information and money movement is happening in like a much more secure way, and like a much more decentralized way. So yeah, I think that's kind of the future we imagine and like the future that we want as well.
Awesome. Let's shift a little bit and talk about sort of the developer experience when working with telepathy. How does the protocol simplify the process of connecting Ethereum with other EVM chains, and what tools or resources do you guys provide to support developers who want to use your product?
Yeah, so it's pretty like simple to use. Yeah, we have some docs, and then you can always try out our demo, and then we have a demo repository that kind of shows how we did the integration. So yeah, you go to our docs, and if you say you want to send a message from Ethereum to some other chain, say for example you want to send like a governance message or something like that, you can just integrate with us. You have your smart contract called like telepathy.send on our router. It's pretty simple. You just put in the chain you want to send to, the address, and the information. And then on the other side, you just have to implement a receiving interface, and that contract basically becomes a receiver. And so, yeah, I think it's pretty simple to integrate. You can like look at our docs, and try it out. We have like a live demo running, so it is this like mailbox app where you can send like a cross chain mailbox message. So that's like a fun demo to try out, and you can also look at the code for that. And then afterwards, yeah, you can like look at the docs and just experiment with it. And we run all our systems to like relay the messages, so you should be able to see your message getting relayed. And then we also have like a few testing frameworks within our docs to help people like write unit tests and stuff like that. And then yeah, if people are working on it and need help, they can always DM us on Twitter or join our Discord and ask us questions. And yeah, generally, I think we're pretty responsive to try helping the developers who, yeah, want to use their stuff.
Awesome. And so you guys are tackling a pretty difficult problem, one being cross chain messaging, and two being ZK generally is pretty sophisticated technology and it's new. But you seem to be taking it in stride, and you've built something that's permissionless, decentralized, and hopefully, it grows exponentially. What are some of the challenges you guys have faced in achieving this level of decentralization and at scale?
Yeah, definitely. So I think ZK is, hard technology to work with, of course. And like making these circuits is pretty hard. I think, as you mentioned, it is like a pretty new field and like pretty new primitive. And so a lot of the systems and tooling for building circuits is not like super well documented or not super well built out. And so, yeah, that's like kind of a fun. I mean, I think it's really fun to like write the ZK circuits, but it is also definitely challenging. And then, yeah, as you mentioned, like even just building the messaging on top of the like client is also challenging, like, optimizing gas costs, like writing these slowly smart contracts, running all the off-chain actors to actually generate all these relay transactions, like all that stuff's, pretty difficult as well. So yeah, it is like a fairly, you know, somewhat complex, I guess, system. And so yeah, I think like, we were just really focused on shipping our product and basically getting it out there, getting the audits, writing everything, writing the messaging layer and like having people use it. I think we rather than like try to ship something that maybe has all chains and wait for like a year while we develop this, we just wanted to ship it fast and ship it early. So yeah, I think that was kind of like our goal in this. And I'm really happy that we were kind of able to accomplish that and get something out there. And yeah, definitely now we're just working on making it better, connecting more chains.
Awesome. Love it. I have a bonus question for you, and this feels cheesy to say, but I'll do it anyways. How has it been working with the Across team, and do you have like, are you a user of the Across product at all? Do you, and how do you enjoy it?
Yeah, definitely. Yeah, we actually have to manage a lot of money on a bunch of different chains for paying gas for our like operator. So we actually do use Across a lot as a bridge to get the money across. And it's super useful because I think generally it's like the fastest one. It's fastest, it's really cheap. And yeah, so we actually do use Across a lot. It's which is nice. And hopefully we can use it more in the future as well on the new chains you guys are supporting, because it is really hard right now to bridge to BNB chain. And so I know that's like one of the new ones. So I'm like really excited to see that. And then, yeah, working with the Cross team has been awesome. Like, I think you guys just did the integration. Like, I think it was pretty straightforward, and yeah, you asked some good questions, and then yeah, it's been really smooth, so I'm really excited to see it go live, which I think should be soon.
Yeah, totally. I think so. Now we just deployed a pretty big upgrade yesterday, and that went smoothly. I see Ryan out there. Kudos to you, Ryan. He was sort of orchestrating a lot of that. But yeah, now that we've gotten that past us, we are working on onboarding new chains. So we'll get to see it live in action pretty soon, which is exciting. All right, one last question, and this is sort of a hot take question, and it has to do with the, I guess, types of roll-ups that you see right now in the space. And optimistic roll-ups have sort of like had their moment in the sun, and now we're sort of heading into ZK season. Do you think that there's a place where optimistic and ZK technology work well together? Do you think one of them will eventually overtake another? How do you see that future unfolding?
So I think for like optimistic and ZK technology, like as the ZK technology gets more advanced and like more ready for prime time, of course it's newer. Like, the main benefit, of course, is that you can the ZK rollups settle much more quickly than these optimistic rollups because you don't have to wait for the fraud proving period. So that's nice. I think even a lot of the optimistic rollup teams have kind of taken the stance that as the ZK technology matures, they're ready to switch over to that whenever it's ready for them. And like they design their system. I know, especially the Optimism team talks a lot about this. They design their system in a very modular way that they can just swap in or out the components, like a ZK component, when that's ready. So I think definitely it's totally possible that a lot of the optimistic teams will end up there as well, like when they feel comfortable with it. I mean, for now, it seems like users are pretty fine with the optimistic rollups, and even the work of a protocol like Across does a lot because it helps the users get their money out of the rollup faster than a ZK rollup, which is nice. Or sorry, it helps the users get their money out of the rollup faster than the 7-day challenge period, and so actually user funds can be sent more quickly thanks to people like Across and like these liquidity layers. So yeah, I think optimistic rollups are awesome. I think ZK rollups, like we'll see how the new ones do. And then I think a lot of them will maybe eventually end up converging, especially as the tech gets better and better.
Awesome. I love it. Perfect. Well, thank you for your time with us today. That kind of comes to the end of the questions that I had lined up for you. So we will go ahead and wrap it up there. So big thank you to Uma from the Succinct team for joining us. Thanks to everybody who is listening in the audience. For those of us who would like to be across in action using Succinct's telepathy, stay tuned for more details coming in the next couple weeks as we build out our first connection using ZK messaging. So, with that, I hope you all have a good rest of your day. And thanks again, Uma. It was really great talking with you.
Yeah, definitely. Thank you so much. Yeah, looking forward to seeing our integration live.
Awesome. Take care, everyone. Thanks.
Take care. Bye.
Bye.